Hello, good morning, everybody. I hope you had a great coffee break. So welcome to one of the 4 outstanding paper sessions, which I'll be chairing together with Jason Eisner. Just as a quick reminder, we have 3 long papers and 3 short papers here, and the best paper award will be chosen from among the papers in the 4 outstanding paper sessions. And I'm going to pass on to Jason to introduce our first speaker.
Hi, welcome everybody. Please try to take your seats quietly. Our first speaker is Michael Noseworthy, who will be talking to us on an automatic Turing test.
Thanks for the introduction. So my name is Michael Noseworthy, and this was work co-authored with Ryan Lowe at McGill University and the University of Montreal. Microphone! Is this better? Great. I think this should be fine now. Okay, so I'm Michael Noseworthy. This was co-authored with Ryan Lowe from McGill University. It's in collaboration with Julien Servin, Nicolas Angela Gontier, Joshua Bengio, and Joel Pinot. And I'm going to be talking about learning to evaluate dialogue responses. So the framework that we're going to be using for this entire talk is that of dialogue response generation. This has been used a lot in recent work, as it doesn't impose many constraints in the dialogue task that you're operating in. Mainly it's been used in non-task oriented dialogue where we don't have a lot of annotation, and it allows us to take advantage of large unlabeled data sets like Twitter corpora, Reddit, or movie subtitles. And the framework, we just have some context, which is a summary of everything that's been said so far in the dialogue. The context is given to some model. We don't put any constraints on what type of model this may be, and then it's tasked with generating some response for the appropriate speaker. So this is nice, this is pretty general, but at the cost of the generality, it becomes pretty difficult to evaluate. So how do we compare 2 models that are doing dialogue response generation? We no longer have a clear notion of success that we can measure between 2 different models, but instead we can give the same context to different models and ask them to generate a response, and then compare the quality of these responses. And what I mean by quality, I'll discuss more in a couple slides, but for now let's just assume that we can measure this notion of quality. So how is this currently done? In most work that does dialogue response generation, we use human judgments. We ask either for pairwise evaluations where we show the raters 2 responses and ask which is better, or we ask them to evaluate on a scale between 1 and 5 how good this response is. But as we know, human evaluations are expensive in both time and cost, and ideally we want an automatic metric, something that we can use day-to-day to guide our research and evaluate different models. So automatic metrics that have been proposed and used in this framework in the past are perplexity, discriminative evaluation, or word overlap metrics. And word overlap metrics have specifically been used frequently in the research community because of we usually are working with large corpora of data, and we have these reference responses that the word overlap metrics apply to. So the motivation for this work was some work we did last year at EMNLP on whether these word overlap metrics actually correlate with human evaluations for dialogue response generation. And what we found is when you're using a single reference response, which is the case in most of these dialogue data sets, Bliss scores and word overlap metrics do not actually correlate with how humans would rate the quality of a response. So the reasons behind this is, first of all, in dialogue you might paraphrase a lot. And a lot of times you can paraphrase with little or no word overlap, and the word overlap metrics would not be able to detect this. But the problem is even worse in dialogue, because we can do a lot more than just paraphrase. We can say 2 responses that are very semantically different, yet still very good responses for the given context. And if we only have a single reference response in our data set, there's no way we can detect both these semantically different responses. And furthermore, the quality of a response depends on the context. If you take a response and slightly change the context that it belongs to, it may no longer be a good response. And these word overlap metrics, they're not taking into account the context at all. They are only looking at a reference response. So when we design our model for dialogue response evaluation, these are some of the observations that we're going to take into account. So the model that we propose is we're going to title it a dialogue evaluation metric, or ADAM for short. And we're going to learn an evaluation metric from data. So the human evaluations that we're used to doing, where we ask users to rate a score, we're just going to try to learn this so we don't have to go to users anymore. We can have an automatic metric that can tell us what human raters would have scored had we done the human evaluation. So we're going to assume human ratings are the gold standard, and our model is seen as a black box here. We'll take as input the context, reference response, and the model response, and output a score between 1 and 5. So the idea of learning a metric is not new. It's not new in the NLP community. It's not new in the dialogue community. It's been used in the task-oriented dialogue before. It's been used in non-task-oriented dialogue. And it's been used a lot in the machine translation literature. And what we're doing different is we're specifically considering the dialogue response generation task, and we're treating it as a regression problem and not a classification problem. So before I mentioned that we need to have some notion of quality, and what we mean by quality is really important here because this is how we're going to be evaluating our models, and it needs to actually reflect what we see as good progress in the field. So we consider two ways of eliciting quality scores from users. The first is just to ask them to rate the overall quality. And we don't give them many constraints here. We ask the worker, here's a context, here's a response, rate this response between 1 and 5. And the benefit of this is that we don't impose any constraints to the workers on what a good response is. We get to capture what users of the system downstream might think a good response would be. On the other hand, it's not interpretable. We don't know what users are necessarily thinking when they see these metrics or when they give us the scores. So instead, we can ask the raters to rate different aspects of a response. And we consider 3 aspects here, and this is by no means an exhaustive list, but we think they were relevant to the task of dialogue response evaluation. So the first one, and probably the one most people would think of, is topicality. Is the response relevant to the context? Are we talking about the same topic? And the next one, probably on most of the talks you hear about these dialogue response generation models, they have a problem where they generate generic responses. And generic responses are good because they usually make sense with the context, but they're bad because they're usually not informative. So specificity was meant to measure this. And if the context, or if a response is specific, then it only works really with that one context that you've presented it with, which is something that's desirable. However, if it's not specific, if it's generic, it can work with many contexts, and this is what we were trying to get at with specificity. And then the final one is background information. So a lot of the data sets that we use with these models are Twitter data sets, Reddit data sets, movie subtitles data sets. And in these data sets, you could be missing information, especially with the Twitter data set. For example, 2 friends could be talking on Twitter about an inside joke between the 2 of them, about some situational context that you no longer have with the transcript of that tweet. So background information would just be a binary value that's just pretty much summarized, do we have enough information to even evaluate whether this is a good response or not? So we did some preliminary experiments to see if we could accurately elicit these different aspects from workers on Amazon Mechanical Turk. And we measured the kappa score when we asked different users to evaluate the same responses for the same context. And what we noticed is for specificity and background information, we couldn't get users to agree for this. So there is probably work that can be done to train the users in order to get them to understand the task better, to do some bias correction and average multiple scores. However, we did not continue down this path because we noticed that we did get agreement for topicality and overall score. And furthermore, for the overall score, we noticed it correlated very highly with topicality. So this is something that users think about when they're not told how to evaluate a response. So we decided to proceed by just asking users for the overall score. We used a Twitter data set. This is what we've used in previous work, and it's a data set that's used in a lot of these non-task-oriented dialogue systems. And we used Amazon Mechanical Turk to collect the scores. So we presented the user with a context and 4 potential responses. It's important here that we use 4 potential responses of varying quality because we want the metric to be able to evaluate bad responses, good responses, and everything in between. So I'm not going to go into too much detail about what the specific models do, but in general, we use 2 retrieval models that just select a pre-written response from our data set given a context, 1 sequence-to-sequence model, and then another human response. And it's important that this human response is different than the reference response found in our data set because the model will be using the reference response. So our model, the ADAM metric, is we're going to assume we have some embeddings for the context, the reference response, and the model response. Our scoring function is learning two matrices, M and M, that learn to project the reference response, or the model response, sorry, into the space of either the context or the reference response. So these can be seen as learned similarity matrices. And then we'll treat this as a regression problem and minimize the squared error between the scores we got from Amazon Mechanical Turk. So when we're getting the embeddings that we want for the context and the response, we have this very small number of data sets from Mechanical Turk. In our case, we have 4,000. We could have run more experiments, but we're going to have, no matter how many experiments we run, we're going to have less data than we need. So instead, we're going to pre-train these embeddings. And then this is beneficial because when we move to new domains, collecting new data will be quick and inexpensive. So we'll use a large unlabeled data set to do this, and specifically we'll use a sequence-to-sequence model, and the one we use is the hierarchical recurrent encoder-decoder. Its sequence is the context, and the output sequence is the response. The lower level encoder encodes the turn, and the upper level encoder encodes the history of the dialogue so far. And we use the embeddings from the upper level encoder as the embeddings for the Adam model. So as for results, what we can see is that the Adam model sees significant correlation of 0.44, whereas the word overlap metrics, you can see on the left-hand side, that there was very low correlation there, and it actually assigns a lot of scores of 0 because there isn't any word overlap. For the system level correlation, we can see that Adam can accurately score the models, can rank them the same way that humans do, whereas the word overlap metrics do not. So before I mentioned that one of the motivations for Adam is that it takes into account the context and not just the response. So this slide is meant to show, does Adam actually do this? Can we benefit from having access to the context along with the reference response? And what we can see, so C Adam and R Adam are the Adam model that I presented before, but they only use either the context or the reference response respectively. And as expected, the best performance is obtained by using both, although we still do get significant correlation if you're only considering one of the two. So the last thing I want to talk about is if we go to use Adam in practice, we're going to be evaluating with new models that Adam has not seen before during training, and we want to make sure that we can accurately score these models even though we've never seen them. So to measure this, we took our training set, removed all the responses from each of the models respectively, trained on the remaining models, and then evaluated on the responses that were held out during training time. And what we can see, there's a large drop in correlation when responses is removed. So this could perhaps seems concerning, but I think it's promising that we can see that Adam detects features that are specific to the models needed in order to predict how humans would rate their scores. And we only used 4 models. So if we had more dialogue models, I think we would see a huge improvement here, and this is a line of future work that we're looking into. So in conclusion, we can learn a metric for dialogue response evaluation using little data. The model benefits from using both the context and the response, as opposed to the word overlap metrics that just use the response. However, we still need to improve generalization to unseen models, which we hope to do by using more dialogue models. Some next steps beyond doing more models is to use our pre-training to learn the interactions between the context and the response. Right now, our 2 matrices, M and N, are meant to learn all the relations between the context and the response. However, this is a huge space, and we can imagine that this would be easier if we can handle this during the pre-training aspect as well. We no longer would have to learn what topics are related, only that the topics are related. And furthermore, this is a response level evaluation. We're only evaluating the quality of a single response given the context of a dialogue. However, dialogue is a process, or it's a sequential task, and it takes place over multiple turns, and usually we care about this global level of evaluation as well. The global level a lot of times is more task specific, but user engagement, we can think of aspects such as user engagement. They're going to be useful no matter the domain you're in, and if you're in a more specific domain, you would be able to include this information. So future work is to think about what kind of global evaluation metrics we should be using in these unconstrained, non-task oriented domains, and how to combine them with the response level metric like Adam. Thank you. I'll be happy to take questions.
This general idea reminds me of the work done in machine translation during in the WMT evaluations, where they don't use blue, they do system pairwise comparisons. So can you comment on that, the relationship between this and machine translation evaluation?
Yeah. So we looked at a lot of machine translation when we were designing this metric, and we see that they do a lot of regression. A lot of these learned metrics are successful and sometimes preferred in the machine translation literature. I think the main difference between dialogue and machine translation is, at least in the non-constrained or the unconstrained dialogue scenarios, the valid responses, or the set of valid responses is very diverse, where in machine translation it's a lot more constrained compared to this. So I think those are the main differences. However, there's a lot of overlap and inspiration from that literature.
Linda?
Can people hear me? Marilyn Walker from UCSC. Hi. Whoa. Marilyn Walker from UCSC. It's a very nice presentation. And I've been following your group's work with a lot of interest. So one of the things that I'm wondering about, well, first of all, I may have missed something. How much of the context you represent? Is it just a single utterance?
No, so we use this level to represent the context. So we encode all the terms in the context and then take the final embedding from the context level. Okay. So this will include the history of the context.
So for all your data, do you have multiple terms of context?
Yep, so we assume...
And you represent both sides of the conversation at the same time?
Yeah, so we assume we have at least, every dialogue has to have at least 2 turns in the context. Okay. But we do have more than that as well. And we randomly sample what we're going to consider as the response and what we're going to consider as the context. So sometimes we have both speakers.
Okay, so now response. Can I ask my question, please? We're wondering about this situation where a local response doesn't look optimal in the context of the preceding dialogue, but it actually is very predictive for the conversation kind of getting more interesting later on.
Yeah, so I think that's a good concern to have when you are modeling these responses. Maybe the response isn't interesting right now, but it will lead to something later on. This kind of model would not detect something like that. So I think this is useful in future work to consider how we can start to measure these more global features, or something that could be predictive multiple turns in the future.
Thanks. Okay, in the interest of time, let's thank the speaker. Yeah.